Morning, guys. Long weekend for me, so it's been a few days off. We'll get started on day 3 of Cocos2d-x game. Just gonna do some housekeeping here, so bear with me. Just want to update some stuff on Twitch. All right. Probably going to recap some stuff. For example, just quickly go through creating the project from scratch, just because it's been a few days. All right, I think I'm good. Cool. Okay, so what are we streaming here? So we can see. So GitHub, all the samples that I do.
It's all about
Twitch,
yield.
all the code, everything.
It's all about productivity.
GitHub, feel free to grab it. We've got the making of a game. There's Cocos2d-x samples. Part of the game's there now.
We are at the pinnacle of automation. We look for new technology every single day.
As well, so just some examples of some
This is called the F80, called the capsule filling machine, and what we do is fill capsules with cannabis oil.
Hold on a sec here. What is making noise?
So in our tablets, we're doing 3 varieties: our 1-to-1, our TH.
Perfect. My Twitch was running in the background making noise. Okay. So let's see if I can even remember where we left off. So Cocos. So you can see I'm running on the command line. This Cocos command. So this is a tool that you get once you run the Python install script for Cocos2d-x. So when we downloaded Cocos2d-x, as long as you have Python interpreter installed, you can run. There's 2 Python scripts in the root. Let me just pop them open here. Training Cocos2d-x. So here we go. We've got download dependencies.python file and setup.python file. Setup will build everything as necessary, move some stuff around, I guess. But the most important thing is it installs. Where the heck am I looking? Tools, maybe? Tools. Cocos2d console. Here we go. So in the bin directory of Cocos2d console, you'll find a Cocos file. So this is like an executable that allows us to create a brand new Cocos project. So that's what we did on day 1. So for example, if I go up a directory, just make a dummy directory. We'll cd into the dummy directory and Cocos. And I actually go up to see the commands I did. I push some stuff to GitHub. Here we go. So the command Cocos new. So we're telling it a new Cocos2d-x project. Give it a name. In this case, it was just named test. And then you've got to give it this this kind of name spacing, this tv.twitch.test. And that's used for Android, probably iOS, because you have to have this unique distinguisher for your app before you push it to the stores. So that's what that's used for. There might be some other uses of it that I'm not quite aware of, but the most important one is it'll name your build output with that name. And then the language, so I know it has Lua, and we used C++, so CPP for C++. And then the directory where you want to create your empty project. So I can go ahead and do this. And it's just doing some magic. So if I go up, we are in training repo dummy. So here we go. So everything's getting pushed into this test folder. That was the name that we gave our project. It's pushing the Cocos2d source code files and all your project files based on the project files you would open based on the IDE that you want to use and code in. So Android Studio, I have that installed, but I haven't used that before. iOS, Mac, that'll be Xcode project. iOS and Mac. Actually, I've tested that on my Mac. It works well. So I can either run in the iOS simulator or I can run it for a Mac. Linux, if you're running Linux. And then finally, what we were working on is ProjWin32. There's a .sln file, which is a solution file for Visual Studio. That's what you open up. You just double click on this. As long as you have Visual Studio installed, it will open up your solution and the one project underneath it. I shouldn't say the one project. The one project we create underneath it called Hello CPP. But it also opens up a bunch of Cocos2d projects, and you shouldn't touch those. So we're not going to work with this. Everything seems to be done. I'm going to delete this now. So we've already got one started. And if you do this on your own, just a warning, make sure you got something to do for about 35 minutes when you open and compile the code, because to compile all the Cocos2d-x into binaries takes about 25-30 minutes, depending on I guess your machine speed maybe, but it's still going to take quite a while. Great. Okay, so let's go ahead. I'm going to open up Visual Studio. We'll get started. So I can't quite recall where we left off. We had the background showing. We had a player class. We were displaying the player. His colors were changing. And that was kind of it. We started syncing some mouse events, and we'll continue on with that. That looks... Which is the one we were working on? Test SLN, Cocos Solution. I think that's the guy. Let me just look. Repo, Cocos2d-x samples. Yeah, this is good. So we'll open this guy up. So let's do a walkthrough of what we got going on. Okay, so everything has to have a main. This is your entry point in all C++ executable. So we've got a main. Here's our main for Windows. This is just the entry point when the executable is compiled and you double click to execute it and run your executable. This is where the entry point is. This is where execution begins. So we don't really care about this. Unreferenced parameters, they're not used. This is what's important. So this is simply here, this main method is simply here to bootstrap and kickstart our game. But the real magic happens in app delegate and then in our code for our game. So if we look through here, there's some predefined sizes. This was built up for us when we used that command line to create our project for us. This was provided. So we're just working in design resolution size. It's very small. That's fine, just to make our game work, to make sure everything is working fine. And then we can up the size. Something you might need to be aware of depending on your machine. The frame rate may drop if you go too large, because you're building it in a debug mode, which has debug symbols built in, and it does tend to slow down execution of your game. When you build in release mode, there's no debug symbols, and it's more of a lean, mean executable. Okay, so here's where we actually enter into after the main method calls the app delegate. This is where we go. So we talked about the director. The director was the director, let's just try to go back. And this is the Cocos2d-x documentation. So we built a scene on Friday, but let's get to getting there. There we go. So the director uses, what the director really does is it's a thing you tell the size of your viewing area, like how big is the window going to be, right? In our case, we're just in the 480 by 320, I believe, size. But this is where we would define the size. Also, we told the director that we want to overlay some diagnostic information. So when we run our game, we'll notice in the bottom left, there's a frame rate. So it shows you the frame rate of your game. It also shows you some OpenGL diagnostics, like how many vertices are being drawn at that time. Just so you can see kind of the overhead that your code may be inflicting on your game, and you can kind of respond to that. So that's part of the director, but then the main purpose of the director is transitioning between scenes. So we would push or pop scenes off or into the director to show them to the player. So we created 2 scenes in our game. We created our game layer scene, which is where we draw our player onto, and we're going to have our bad guys and stuff. That's where the game magic happens. And then we had the menu scene, which is the opening menu when the game launches, and all we have is a single button called play. So the director, when it launches, or the application when it launches, the director will push onto the running scene, the menu scene, the game menu scene. So we'll see that. So this is just to display the frame rate on the director. We talked about that overlay. The director, we also set the frames per second. Right now it's 60 frames per second. You could drop that down to 30. Games look good at 30 as well. 60 is a little cleaner. And I can't remember the maximum. I think it's like 97 frames. If you go any higher than 97 frames, just the human brain and how fast you can process things, it's irrelevant. Beyond like 97 frames, I can't remember the exact number, but it's something like 97. Anything above that, the brain just it's irrelevant. It's just a waste of overhead. Because obviously the more frames you want to display per second, that means more drawing, more rendering, more calculations are occurring, and it will definitely slow down your game the higher the frame rate you want. So it's a fine balance. For our game, though, it's trivial. I mean, 60 frames is totally fine. The resolution, that's where we set the resolution of our game, 480 by 320. Just some content scaling, so to scale. That's just being done here as well. But that's not important. This is important. So we had to set the default path of where our resources were, and it's in that directory. So if we open up repo, Cocos2d-x, samples, Solvolution, right here. All we're saying here is set the default directory for where your images are, where your sound files are, where your shader files are, fonts are, XML files like levels, all of that would go into here. Shared core, this is something we created for our game to have shared kind of like static data always accessible to other code within the game. So we just stored like the context of what's going on at that time in core, and we'll look at that in a second. So then we just create our game menu scene. We create an instance of it. So we get a pointer to a Cocos2d-x scene, and we push that pointer onto the director and tell it to run with that scene. So display that scene. So the game menu, the game menu. We've got our create scene right here. That did the magic. But the important thing to note is we actually push a layer onto that scene. So if we go back to the documentation, a scene has a graph, and just look at it like this. It's really a tree, but just think of this as pushing children onto the root, and the root is the scene itself. So the menu scene is the root, and we push a layer onto it, and that layer will have menu items on it, or sorry, a menu on it. That menu will have menu items on the menu. So all of these things get added under the single root node, and then that root node we push on to the director to display. So we can kind of look at actually this thumbnail, this image, and we can tell right now there's a scene. That's the whole thing. Underneath there's a layer. So the layer would encompass the whole thing as well. It's almost like the scene, but the scene is kind of this special object that always has nothing above it and always has stuff under it. So we've got this layer, and on the layer you can tell start game. That's a menu button. So this is a menu here, and then on that menu there is a menu item, which is the button start game. So we already know we've got a scene, we have a layer, we've got a menu, we've got a menu item, and this button start game. You can see there's some labels up here. So Cocos2d-x has label objects. So you can see there's a label player 1, a label player 2, and also the 00, which is the score. I'm assuming those are labels as well. And then in your update logic, you would just update your score based on the gameplay. And we'll do stuff like that. And I'm not sure what this Super Cocos Aliens is. It's probably a label as well that they just use. A label's pretty easy. All you do is you define the Cocos2d-x label. You pass it a font. In our case, we've got some fonts in our resource directory. So this kind of, robotic sci-fi looking font, and this other kind of like an old calculator display, those old LED display fonts. So when we write stuff out to the screen, we'll just be using a Cocos2d-x label most likely, and we'll tell it to use one of these two fonts, and we'll just pass in a string of text we want to display. So it's pretty simple. And obviously we push it onto a layer or push it underneath a menu or wherever we want to layer it in this scene graph. And then when the scene goes on the director, everything just gets displayed. So a better example of the scene is here. So the scene, there's a label. You can see this label node. So it's just one big label that they just tabbed across, I guess. Some static nodes. So they've added some static sprites here, I guess. I don't know exactly. Some sprites, the menu, which has start game, this title, which is most likely a label as well. Anyway, we won't dwell on that. We've got our own thing going here. So our game menu scene, we simply created the scene. It's just an empty scene. We push the game menu layer onto that scene. During the init portion is when, if we go back to the app delegate, as soon as we run with scene, we're going to call that init method. So let's go back to game menu. We jump into the init method. We get the current window size. So we call the director, and you may remember we're using that singleton pattern in Cocos2d-x a lot, where we don't instantiate a director. We just call this static function off of the director called shared director, and it gets us the pointer to the director that's in memory. So that will get us our window size 480 by 320. We're creating a sprite which takes up the whole background. It's our loading image, just a big image. We've got our button sprites. This is our sprite sheet, where we actually chop off a portion of this image to display individual buttons. So this sprite sheet, let's quickly look at it briefly. So buttons right here. So it's composed of a lot of buttons. All we're doing is saying, using a rectangle, we can actually cut out a chunk of this image and use that as a sprite. So we've cut out 3 little chunks of that image, which give us the play button unpressed, the play button pressed, and the play button disabled. So we use these 3 sprites and we pass them into the menu item sprite. Okay, so we create just normal sprites, which will create actual textures based on a PNG file in memory. And then we put those images, those textures, into a Cocos2d-x menu item sprite. When that menu item is clicked, we call a function called onNewGameClick. So this is when we pop off the scene, the game menu, and push onto the director's scene, the game layer. Okay, so we're going to create a game layer scene and push that game layer onto the Cocos director. So then that will be what's running. So we go to the game layer. As soon as that gets pushed onto the director's running scene, we call the init method here, and we display the game background, takes up the whole screen. We put a really low Z order on it. So that means it'll be in the background. Everything that's drawn will be drawn on top of it. That way the background is always exactly that, the background. We've got a blood overlay, full transparency. We'll push more into that. We'll actually make it less transparent as you're taking damage. We've got this in the foreground, way in the front, 1,000 up. So that will overlay over everything. And that's probably how we want to see it. As we take damage, we definitely want to have that fog of war, blood in your eye effect going on. And that's what that'll do. So we've got a listener to handle mouse events. So mouse down, mouse out, mouse move. We'll do the mouse down next. I don't think we did anything with it. We push the listener onto the event dispatcher. This is just the magic to sync events. Simple as that. And you can find example code out on Cocos2d-x site for this. But this is just generic. This will be the same for all games. If you want to handle mouse events, you just would do this. And this is just the name of the function that you want to call when this event occurs, when somebody clicks on the mouse button. All right. So we talked about frame rate. We have 60 frames a second. So what happens is on each frame, the game will call this update method on all objects that are in scope and running. Definitely the game layer will be running, so we'll be calling update every 1/60th of a second. We simply push the function call, though. All of the magic is going to happen inside a player move, this function. I mean, I guess I could have done it in update, but update will also handle not just player move. We're going to have other things like the bad guys have to move. We're going to have a function that we check every frame to check the winning, see if the winning criteria is met. Like if we killed off all the bad guys, therefore we move on to the next level. So the reason why I put the player move logic in its own function is just we've got more logic that has to be called in updates. So we kind of want to have a separation of concern and only for the player move have it in its own function. We pass in the delta time, the DT. This is just a small fraction of the time that has elapsed in that 1 second period, right? So we're going to use this delta time quite a bit. We need to actually use it to define, okay, the target angle isn't used, but for when we actually try to simulate movement of the player, he's only going to move a small fraction based on the delta time that has elapsed between frames. You'll see what I mean. We're going to do that in very soon. So all that's happening right now is we're capturing some player stuff, but we're not actually moving the player. Right? We're getting his previous position. We're getting his current position. We're getting his target position, which is not sure if I want to keep this. We'll look at this in a second. And we're getting his target angle. We need to know his angle. I wish I had a drawing, something I could draw on, but I don't. We need to know the direction in which the player is going, right? So that we need to know one of the directions the player is moving, because when we simulate the movement on every frame, well, we need to know, you know, he's moving at a certain speed. That's great, and we're gonna code the speed or the constant rate at which he moves. But we need to know what direction are you moving towards, right? So the target angle will give us that direction. And we use that based on where the button click occurred. Like, let's say I click right up here. That's where I want the player to move. Well, the player can be down here in the bottom left quadrant. He could be in the bottom right quadrant. So he's going to move towards that click, but we need to know the angle at which he's going to move on every frame to reach that click point. So we simply use an arctangent function, just some trig. All you do is you pass in the delta between the y and the delta between the x to get that angle. Now, when we simulate movement, we're going to use a sine and a cosine function. The cosine we'll use on the x, and the sine we'll use on the delta y as well, and you'll see that soon. We'll be doing that next. So anyway, no movement is occurring. We're just kind of calculating some of the important information before we trigger a move. Okay. So where else did we get to? Let's quickly look at player. So player, and we'll run this game. You're watching, you're listening to me talking about the code, but I'm assuming people were here last week. Fortunately for us, we already did the initial compile, which compiled this Box2D, Cocos2d, recast, and spine projects. You can see them in my solution. Those took close to 30 minutes to compile. All right. Anyway, so this is the game. We talked about the director pushed the game menu scene on first, hence why you see the game menu scene. All it had was a button called play. When it's clicked, it calls the onClick function, which in turn replaces this scene with the game layer scene. We'll do that in a second. This is the OpenGL vertices drawn, OpenGL calls drawn, and our frame rate. Our frame rate is holding constant at about 60 frames a second, which is good. When you see a drop in frame rate, then what you want to do is you want to understand what's going on. A drop in frame rate when you maybe click the play and you're popping a scene and replacing a scene, and you're obviously doing some logic, that's understandable. But you know, concerns would be a drop in frame rate when we're simply moving, a drop in frame rate when we have a reasonable amount of bad guys on the screen trying to attack the player. So this kind of helps you see, okay, I'm getting a drop in frame rate. When did it occur? You can actually use some diagnostic tools in Visual Studio as well to actually see some certain events that are going on. You can actually drill into code and see what functions are taking overhead. So we won't need to do that, but just be aware it's available. Okay, so let's click on the play button. We'll pop this scene and replace it with, we got an exception. Let's just see here. We've got a runtime exception, read access violation. So let's just see what's going on. So we're getting that when we're calling random color. So let's just see. Let's just rerun this. See how far we get. Nothing has changed, so let's see. Player color. Maybe player color doesn't exist on core. Let me just diagnose this. So player color is here as a public. It's not set, but that is fine. Let us see what is going on. Get random color. Unable to read memory for player color. Well, let's have a quick peek at core and see what may have occurred. Maybe we left on Friday in an inconsistent state here. It's entirely possible. So we'll look at our header file for core. So we've defined a variable, public variable player color. Now I'm actually going to change that to a private, and then we'll follow our convention of wrapping it with a getter and setter. So I'm going to do that anyway. Not that that's our problem, but it's just color isn't initialized. So on shared core, I could initialize it. But what I'm going to do is let's do the smart thing. So let's jump into our code and let's follow the convention we started on Thursday and Friday, where we wrap, look at the right header file, where we wrap everything in a getter and setter. This will take 2 seconds. Let's quickly do that. And then we need to actually set this as well. So color is defined in resources, I assume. Let's just look. So we've got our color enumeration, and this is the color of our player. He can be red, green, blue, or none. When the game first starts, he doesn't have a color. So that's the purpose of none. So let's follow a naming convention of underscore, and we'll say player color, and we'll initialize it to none. So we can go color. And what do we want? Well, we want none. Okay, so we'll initialize this to no color. And then I'm going to just copy. So get player color. And, set player color, where we pass in a color enum. And we get player color and return a color enum. So the mechanics of this game, if you weren't here before, the idea of this game is simply you're this cell and you start off with a random color, let's say red. The bad guys start slowly appearing, but they also have 3 different colors. They're either red, green, or blue. If you're red, you can only eat or attack the red bad cells. If you're red and a blue cell appears, it will try to attack you. So it will approach you, and if it hits you, then you're going to take damage. But the cool thing is every dozen seconds, you randomly switch to a different color. So all of a sudden, the attackers that are, dangerous to you could then become the victims, because you're now the same color as them. Hence, they're vulnerable to you attacking them. So you can just go and touch them to eat them. So as long as there's a hitbox and a collision that occurs, we do the explosion animation and some sound effects, and you get a point because you ate the bad guy. So that's the general mechanics of the game, and it's roguelike. It just randomly, it just gets harder, progressively harder as you finish a level. Things get faster. There's more of them, and eventually you just will lose. Okay, so we're wrapping that in a getter and setter. Let's go back to player, get random color, core. So no longer do we access that directly. We just call the getter, get player color. And we pass in the current player color into this random function, because if you're already a certain color, we don't want him to become that color again. So if you're none, which we start out with no color, you're just randomly given one of the colors. if you aren't none, therefore you're either red, green, or blue. Based on if you're red, you can only become green or blue randomly, right? So you never go back to the same color, assuming our logic works. So we've got a setter now to set player color, and it's a function, therefore color gets passed in as an argument. So we're getting a random color based on his current color. We get that back and we set it in the setter. Now this is all set inside of core, our core class, because it's going to contain all of our in-game important stuff, no matter what scene we happen to be on. Core is always in scope and always holds the data. It never loses the data. Okay, so that looks better. Let's go back to the player. Assuming we are not calling player color directly too much. And we may actually replace this. Maybe there's no need to have get color on the player. We could just simply call core color, get player color. But we'll refactor as we see fit. We just want to make it work. Let's run this. So we know color is now initialized, so we shouldn't get that memory exception. It's not undefined because we went to the core header, and before it was undefined, right? It would be undefined. Clearly we've got an issue, but we'll look at that in a sec. Before it was undefined, it was also public, but it was undefined. But by assigning it something, it's actually initialized in memory with this value. Okay, so what was our error? Our error, reference and function. We got a linker error, set player color. So it looks like we still got some color references using it the old way. Let me just see. So reference and function, private void, player change color. Change color. Private void change color. So let's go to player. Get random color. Player get color. Let's just see here. So the problem occurs in there that it's trying to call our core set color, but it's not finding core set color. Set player color. Set player. Oh, geez, sorry. So I define them in the header file, but that just defines the signature of the functions. You can see the green squiggly under it if you squint. We haven't actually created in the class file. So Visual Studio actually gives us the ability to magically create this. So it's created, and we'll create the getter. And then I'll jump to the class file. Okay, my mistake. So set player color, a color's coming in. We want to set our underscore player color to be equal to whatever we pass in. And we have to give it a name, so we'll call it color. And then get just returns player color. There, that's what I was missing. Okay. Okay, let's play. Exception thrown, read violation. Let's just have a peek. Return this dot play color. Let's just look at our call stack and see what's going on here. Let's change color. It's having a problem accessing the color. Let's just have a look here. Let me just run this again. It's like I'm losing player color. We did initialize it to none. Player color. It's like it's getting dropped. Well, for now, here's what I'll do. Since it's the first run, shared core init, let's jump to our init and we'll initialize it. This is where all the core magic happens when you first run the game. So we will default player color to none. So we can do this. And the keyword this you don't need, but I just do it so you know that we're in the current class instance. And we'll just set player color to color none. And we'll try it. So that's coming from the init. We're setting our color. Color is equal to none, so that's a good sign. And then when we call the getter here, this player color. What is going on here? Let's just have a look at locals. This player color, unable to load memory. What am I doing? Let me just look here. What am I doing? Color is fine. What is going on? I wonder if it's because I have just wondering if it might have something to do with my enum. Yeah, this is a strange one. I don't know what is happening here right now. Read access. Let me just copy the whole deal here and have a look. Somebody help. Copy constructor. Reading, you have to create a new object for each entry in the archive, something like. I just want to look at this setter again. So it was already none. So me doing that init is unnecessary. But where is it getting lost? So core, get player color. Where is it getting lost? Shared core. Let's just hover over. Player color is there, set to none. We return shared core as a pointer to its memory location. That's great. So let's step into. So we step into. I don't want to see this. Step over, step over, step over. So let's have a look at non-static. Okay, so let's step in. So let's have a look at our scene. So game menu, let me just see here. So game menu, let's see if it references core. So it doesn't hold an instance of core. Game layer init. Okay, let's try to move on here. So see if we can add this to the watch. Player color is still none. Except for now. Get player color is undefined. Let's just look at the player header. So we've got a private, maybe I just did not initialize core properly. So we're in player CPP. Let's look at player header. Sure, we've got an instance. We've got a variable to hold an instance of core. That's great. But we're not actually setting that anywhere. So let me actually, just for my sanity, let's find everywhere where core is referenced. Yeah, exactly. So mistake on my part. I guess we did leave this running in an inconsistent state, unfortunately. So what I'll do is the problem occurs here in that core is not initialized. So we need core, shared core, which is our singleton. So now core is initialized with a core instance, with a core object. So that was the problem. I suppose I should have looked a little deeper. Where did I do that gross mess of just initializing the color to none? Well, it doesn't matter. We'll I think we're good now. So let's run this. So good. Player color none set. Yeah, I think we're good. I think we are good. And I don't need this anymore. Cool. All right, so we are in game layer. So we're in the init of game layer. All we're doing is putting the player on, getting a random color, and it should just change color. So let's just have a look. The game starts out blue. 12 seconds, then 1 second of blink. And the blink should warn you that he's going to switch color. There's the blink, and then he goes green. And then in 12 seconds, it just repeats until either you lose or you win the level. You just keep switching colors, and you attacking bad guys of the same color. Good. So we know that works. I'm clicking on the game layer, but we're not moving. So we definitely want to do that. So let's go ahead. So let's go ahead inside of core, and let's go and start adding some stuff to it. So I want to create a constant. We want to get some movement on this guy. So unsigned int, constant player speed. So I'm going to set this to, let's say, 140. So what this is going to be, I guess we don't have an unsigned int. If I can spell. Okay. And we should use the prefix of, or the suffix of u to define unsigned integer. You don't have to. It's just the compiler will give you a warning if you have kind of verbose warning set. Okay, so I want the player to move about 140 pixels every second. So that's what this is defining, is the player's speed at 140 pixels per second. Now, it doesn't really do that for us. I'm going to have to code against this constant. But yeah, that's what we want to do. So we've got a constant. Let's player vars, player variables. So for the player to move around and stuff, we need to define some things. So we already got target position, previous position, target angle, player color. That's great. But I guess I won't put player vars because most of those are already player vars. I want to have these movement variables. So we're going to define unsigned int player speed, and we'll default it to that constant. The reason why I've got a variable for the player speed is because it's going to change. We're going to add some power-ups. I've got a power-up. We've got a power-up on our game sprites, which is, you can see the little alarm clock. That slows down everybody else's movement. So that has nothing to do with player. Oh, here we go. The lightning bolt. When you eat that power-up, when it appears on the screen, you will speed up. Like your speed's going to double, let's say. We'll figure out how much. We'll fine tune how much he wants to go, but how much faster he'll go. But then his player speed during that power up period will definitely increase. But by default, he is K player speed. So he'll be 140. Perfect. And you're going to find out where delta time comes into play in a second. We briefly talked about that. Bool. I want to add a Boolean called player moving, and we'll default to false. So this is going to allow us to, when the mouse isn't clicked, the player will not be moving. So the only time the player moves is when you click on a location for him to move to. So when the game starts, we want to say the player is not moving. So when we're updating and doing the magic of movement, we won't move him at all. We'll just jump out of that function. So until a button is clicked, this will always be false. Okay. So that's kind of that. Now let's wrap these guys. So just like we did with our color, let's do our convention of a getter and setter. So we need a getter and setter for speed and for player moving. So void set player speed. Hey, you safe. Who's Adam? I'm not Adam. Is there some Adam on here? Not sure. All right. I'm Trent, by the way, guys. Okay. So set player speed takes Let's see if I can spell it the first time. Perfect. And the getter returns unsigned int. So we want to get player speed. And that takes nothing. Then we want void set player moving. And bool takes a boolean. And the getter returns our boolean. So, geez, it's early on. It was a long weekend for me, so this is kind of like my Monday. Player moving. Perfect. So we wrap those. Again, the green squiggly is telling us we've defined it in the header. So we've created our signature. We've created our header file and specified what we want, but we haven't actually created these functions yet. So we can use our little helper, which is that little light bulb. We want to create. And create. Now let's jump into core CPP and actually do that implementation of these guys. So let's do it. I'm just going to go up top, just have a look at everything. We've got our getters and setters. Here's our new one. So set player speed, this underscore player speed is equal to whatever gets passed. And again, the only time we set this player speed is when he chooses a power up that does the speed power up. And then for the getter, we simply return back underscore player speed. And remember that defaults to that constant of 140, which is the movement in pixels. So player moving, same idea. This underscore player moving is moving, and I'll name it is moving. Okay, and then finally our getter is going to return this underscore player moving. Good. So we've got those guys going on. Let me just think here. So we've got that players moving by default as false. Cool. Let's just look at the core init quickly before we leave here. So all of our game sprites are loaded. That's these guys. Remember Thursday or Friday, or if you have a background in creating kind of simple 2D iPhone, Android games, then you'll probably be familiar with the idea of a sprite sheet. And the sprite sheet will typically also come with an XML file called a plist. The plist is here. Image game, here we go, sorry, game sprites plist. So not only are we setting in the Cocos2d-x sprite cache, see I got an instance of the sprite cache, I'm setting all of this single image into the sprite cache, but really since we passed in a plist, what this plist does is it gets each individual image out of this sprite sheet using its location with all of this data. So it can say, you know, if I want the speed up power up, then it will actually clip out this little fraction of this PNG and return this as a sprite to our game. Therefore, sprite sheets are great because you just have one big texture to deal with, and memory does better with a big single texture that you kind of slice and dice than having a bunch of individual sprite textures loaded. Yeah. So the sprite cache uses the get instance method, therefore it's a singleton. We'll see get instance a lot in Cocos2d-x. Everything seems to be a singleton, which is great. That means it's always in memory, and you can't reinitialize it multiple times and chew up memory, right? There's always just one instance to get all the time. So that's great. Okay, so we load up the sprites, then we start extracting from those sprites our explosion. That is great. That's all this is doing, is getting our explosion animation. We create it as a Cocos animation object, and we push that into the animation cache with the keyword, with the key explosion. So whenever I call the animation cache get instance, I can get an animation by simply passing in this string constant. And this is actually a constant. And we'll move this probably into our resources header file as a constant later. For now, I'll just hard code it. That's fine. Then our sprites for our player animation. So we've got his red animation. Sorry about that. Just got a call. I'll push into voicemail. Okay. Right, so we've got our animation for our player, red, blue, or green. We saw that when we were running the game. And to call those animations, we simply use those constants. And the rogue, that's kind of our cancerous bad guy. Perfect, so we've got rogue and our explosions. So far, so good. Perfect. So now let's go ahead and move to our player. So player.h, let's see what we want to do with this. So we've got our core, we've got our reds, main sequence, get color. Yeah, I think it looks okay so far. He extends sprite, perfect. Okay, let's go to the implementation of player. Now, we know we got to do some movement magic with this guy, so we'll have some movement done. Yeah, maybe let's go to game layer first, because this is where we sync our click events. Sorry, I just got a message here. Okay. Okay, so game layer CPP. Let's handle our mouse clicks and all that. Okay. Schedule update, sounds great. Let's also, this is our initialization of our game. So every time our game level displays and we're about to play a level, this code is going to run. So what we want to do is you know what, guys, I might have to take a break. This guy who called me is texting me, and you know what, I'm just gonna give me 1 sec here, guys. Okay, sorry. Good. So let's reinitialize our core. So what does that mean? Well, core, did we get core? Let's go ahead and core is equal to core shared. That's our singleton. So now let's just make sure we reset everything. Set shared core. Oh, it's core star. I can just use the auto keyword, but it's a pointer to core. So set cool. So player color we don't care about. Player moving though we should set to false. That way the code we're about to do right now for the movement will just exit out, because the player isn't moving yet, because if we just started a level, clearly we haven't clicked on a location for our player to go. Let's just see if there's anything else we should reinitialize. Target angle, we should reinitialize that to something. Target position, We'll leave it for now. That's fine. The important thing is player moving is false. Okay. So let's scroll down. So in the update, we call the player move. So now let's get down and dirty with player move. Okay. So first off, we want to just short circuit this function and exit out if the player is not moving. So let's go ahead and I'll do it underneath the core. If core so if he's not moving, we simply want to return out because nothing's been clicked. This player move will get called on every frame because this update gets called on every frame. Therefore, this call will get called. We just want to short circuit out if we know there's no movement going on. Okay, so we've got that. Now, if target position, yeah, we added that. I don't think we need this anymore. I think the player moving should do that function for us. Okay, so now what do? Core stores the player's previous position. Why do we store the player's previous position? Well, this will be the previous location on the last frame that was drawn on the screen. So we want to know what his previous position was so that we know how far he had moved between then and now. Okay, so we need to know his previous position. We need to know his current position, which is where he currently is at. Get target position. That's important because that's going to be where the mouse click, when we click the mouse. So let's go ahead and actually just quickly verify on mouse down, we're setting target position. And that's fine. We are. So that is good. We're setting target position. You know what I might do though? Let me do this. Let's create a function because I know we're creating this on Windows, but you can download this source code from GitHub and you can open up the Xcode project file and build this out for iOS. That's completely valid. If I was streaming on my laptop, which is an iMac, my MacBook, it would you would see that in the simulator. And I'm actually handling touches on my Mac for this game. I downloaded it over the weekend just to play with it on my iPhone simulator. So what I want to do is, I don't care if it's a mouse click or a touch. The thing is the same. So I'm going to create this method, just void. And we'll add this to our header file in a second because you obviously need to define it there. We'll just call it process event. And the base class in Cocos is event. So you can see there's an event here, but mouse has a mouse event, but they all just derive from events. So we'll pass in the event. And what will we do? So if the event is null, we obviously can't do any logic, so we just want to bail out. Let me just see if create declaration in there. Perfect. Let me just see. If we go to our header file, it should have done it. Game layer, process event. I'm going to create it as a private function. Okay. And really, these should be as well. Okay. Close that. Now let's start adding our logic. So I guess the first thing we can do is if on mouse down, instead of doing this, we will call that function process event, and all we do is pass in the event that was passed into it. And we can do the same with our touches here as well, but we'll do that in a bit. Okay, so process event. Okay, so we need to get a vector2 object, which is part of Cocos2d-x. It's simply a point, right? It's a a vec2, which is just simply a structure that contains an x and a y value, which is a point on a screen. Since it's a two-dimensional game, we only need a vector 2. We'll call it location in view, and we'll just initialize it to a 0 vector. So 0. Perfect. But it won't be 0 in a second. So what we need to do now is let's kind of introspect and look at this event. We can actually, it's got a get type. So we want to do a switch against. If you're familiar with a switch, it's just like a bunch of if statements almost. It's like get type will return back mouse or touch or game controller, whatever the input device is. In our case, no pun intended, I'll handle the case mouse. So event, what is it called? Event type, I think. Perfect. And we want to handle mouse. Brilliant. So you'll notice the other controllers you can use in Cocos2d-x are your accelerometer on your device. So you could build a game that uses that for input. Custom, I guess if you've got your own custom driver to some sort of, like a game, like a steering wheel or something like that. Focus, not too sure what that is. Game controller, like an Xbox controller or your Steam controller, that can be used as input, and you can handle all the events for your game controller. Keyboard, obviously, mouse, and then touch, which is obviously what you would use on your smart device. For now, mouse is great, and I'm going to add a break, and I'll add the logic in here. I like putting the curly braces inside of my case statements if I have a lot going on in them, and we're going to have a few lines of code going on in here, so I'll just put it in curly braces. So let's add the case statements for the other events too, just so when we want to upgrade this game to handle different devices, we're somewhat there. So game controller will case, let me delete this because I'm just going to copy. So I'm going to have to add this for the other touch. Control V. What else can we handle? I guess keyboard maybe we'll do. We're not going to use the accelerometer. I mean, the accelerometer might be kind of cool because you would tilt almost like, I don't know, if you ever play those games where you're like controlling a ball as it's rolling and you control the tilting action to make the ball kind of go to the left or the right. The accelerometer might actually be kind of a cool mechanic for this game because we're controlling this little virus or this cell, and the accelerometer movement might be interesting. Maybe it's something we'll do. I'm not going to go overboard though on this game, but it's going to be on GitHub and you can do whatever you want with it, so you can go overboard if you feel like it. So we'll just log out. We don't handle yet. So it's just a log. It would just be in the console log when you're debugging. I could throw an error, but whatever. I should actually just return. Return versus break. What's the difference? Well, return will actually return out of the function. Break breaks out of the switch statement. Okay, it would break out of this last curly brace on line 151. Okay, so let's handle just the mouse event. So I could actually probably, oh shit. I had this all typed out in the mouse event, but it doesn't matter. So let's cast this event to a mouse event. Perfect. Spelling is right. It's a pointer, and E is our event. So there. So now we've got, if we hover over auto, we can see we've got a variable of event mouse pointer. Brilliant. So now we can get our location in view. So our location in view will be the vec2 of where the mouse click happened. So mouse event, and let's get location in view. So get location gets the location of the button click on the screen. That's great. Location in view gets that as well, but it does it after applying OpenGL. Like if we look at app delegate quickly, and right here, we actually are creating an OpenGL view, right? So we're actually underlying Cocos2d-x uses OpenGL. And the thing with OpenGL is it's a 3D framework, right? API for 3D graphics. So really, the point that you click on the screen will be different after it's interpreted through this 3D view than it would be on a 2D view, if that sort of makes sense. So by getting location in view, what a nightmare. By getting location in view, we're actually getting the XY coordinate of your button click as it would be viewed through our OpenGL view, not just kind of like a plain true dimensional 2D Cartesian coordinate system view, if that makes sense. So we have to kind of go through OpenGL to get the location, because OpenGL you can kind of set some you know, things that represent your 2D environment, but it's truly a 3D environment, but it looks 2D. So this will get us our XY coordinates as they're truly represented in this game area. So we use get location in view. If we just did get location, we would have bizarre movement results because the location coordinates would not be as you'd expect. You might move in a totally different direction. Like OpenGL's coordinate system is not the coordinate system that Cocos2d-x kind of portrays to us, where a 0, 0 is the bottom left-hand corner. That would be like maybe right in the middle on this OpenGL view. Anyway, I'm not going to harp on it. Just know that we want our location in view, not our location. Cool. Now let's do our magic. So our switch, we broke out. You know, do I need these curly braces here? Maybe not, but I'm going to leave them anyway. Okay, so now let's do a little magic here. So let's go ahead and get our point. So the point is simply, you know, vec2. It's just vec2. Doesn't matter. Vec2, we'll call it our point 1. So we need 2 points. We need the current position, and we need that location in view. So the location in view is where the button click occurred. This is where the player currently is. So get position. So we added this on Friday. So we've got our point 1, which is where the player is. And then now let's first define the angle. Let's get the angle between P1, which is our player's position, and the click location. So how do we do that? What we need is a delta X and a delta Y. Okay, a delta X and a delta Y. So let's define these. Location in view. And all delta is, it's really simple to calculate. It's just our location we want to get to minus the location we're at, which is the player's location. It's not really it's the Y. It's the Y of the player's location and the Y of the click location. And then we want the exact same with our X coordinate. So let's get our delta X. Exact same thing, but we're using the X. Cool. Okay, so this is where you get to do a little bit of trig. Extremely simple. So let's go to, did we define core? No core. So I'm going to define core, pointer, core, and we'll call our singleton, which is shared instance, shared core. And I want to set player, no, what I name it, target angle. Target angle. So that's our target angle of where we are. I'm just going to move this up. I don't want that confusing our code. And I might move this here. Okay, so now let's do our target angle. So float angle. So all we need to do is arctan2 f, since we're working with floats, and we want to pass in our y, and we want to pass in our x. You can see it's wanting our y and our x. And this will calculate an angle in radians, right? So 2 pi is how many radians there are in a circle. Okay, so 2 pi, we know pi is 3.14. So 2 pi is 6.28. So there's 6.28 radians in a circle. So think of radians as a unit that we use instead of degrees. We can calculate in degrees, but you know, we would have to divide that by 360, and then we introduce a division, which is a mathematical operation that takes clock cycles. So, you know, let's just use radians. So we get our angle in radians, and we want to store that angle because we need it every time that we're going to actually move. So when our player move, we're going to handle the stuff we're setting here. Okay. So right now we're just setting this stuff. We're not using it yet. So I guess I can move all this up together. Cool. So we've got our target angle. Now let's do this. So let's get the size of our game screen. And since we set the size of our game inside the director, we can use the director to get our game size. So get win size. And now I want to create a clamp point. A clamp point. And what a clamp point is, I'll show you. Location in view. Get clamp point. And so what a clamp point is we're setting kind of a minimum and a maximum. Like we're setting a 0, and then we're setting our screen size as our maximum. And then what we can do with this clamp point is say that our click must be within these 2 points. So the first point is going to be a 0. So we'll go vec2 and 0. That's just, you know, the x is 0 and the y is 0. And then we want to define a vec2 for the maximum range of what our click can encompass. And that will be the size of the window's width and the size of the window's height. That way, if a click somehow came through here but was out of the screen area, then what would return is the maximum of this clamp point. Like I'll show you in a sec. So we're still not quite done. So let's set the height. Okay, great. So we got this clamp point. And now let's use this clamp point to get our position. So I can just straight away go set target position. So what do we got? Core. I'll explain this in a second. Set Target position is our clamp point. Okay, good. So what has happened here? There's three things really going on here. We're saying our button click has to be whatever it is. It's X and Y is already defined. That's a given. We know that. But we're just saying that it's got to be within the range of 0 and the upper bounds of the maximum size of our screen. If it's beyond that, then CP will be the maximum of this clamp point, which is the screen's maximum size, like the farthest width and the farthest height. So the very top left-hand corner, let's say. Or it's got to be on the minimum side. If the X was -1 and the Y was, let's say, 10, well, we'd have a problem because the clamp point is saying, well, the X minimum is really 0. So that X would become a 0. Hopefully that makes sense. So we're just making sure that our target position we're trying to move to, that click, is within the game screen. Awesome. And we added that funky player moving Boolean. So since a button click did occur, he is now free to move. Cool. So now let's go back to that the player move stuff. Okay, so where was that? I think we're good here. Process event, sweet. Okay, I think that's okay. Go away. Cool. So let's look at player move. And let's actually create some movement on the screen. So we get our core. If he's not moving, we return out right away, but we set player moving to true, so that's fine. So let's get his previous position, his current position, and where the click is. Previous position is his position in the last frame. His position is the position now, and this is where he's going to. So calculate the angle for the player to move. Did we already do that? We already set that. So we've already done our trig. So let's turf this. I'm just commenting it just because I'll turf it later. Okay, so let's go ahead and let's do something here. These are the three things we really need for now. Let's go ahead and define the distance between the player's previous and the player's current position. We want to see how far he had moved. So this is just kind of a bit of a sanity check. So player's previous position, get distance, and we want to pass in the player's current position. So just player position. So I'm just going to have a little bit of a logic check here. If distance is greater than 10, so if for some reason something schizophrenic happened in our game and he moved 10 pixels from the previous to the current frame, then I just want to log crazy move happened. Nothing exciting. I just want to make sure our game is kind of responding as I expect. Since this gets called 60 times every second, moving 10 pixels in 1/60th of a second is crazy. So crazy move has occurred. So now the actual magic to make him move. So let's go ahead. We need to calculate some distances here. Previous distance is equal to player previous position. We're just going to do something similar to what we just did above and get distance. And we want to pass in target. So we need to know, how far he's got to move. His target position. And now let's get the current distance. So like where the player, so float using where he currently is. We'll just call it current distance is equal to player position It's his current position. And again, target position. Get distance. Cool. Now, before I go, the last thing we want to do is we want to go into core. I'm just doing this now, something that's going to occur at the very end, but player's previous position has to be set to the player's current position. That way we store between frames player position. That way we store his current frame position as the previous position. So when we come into this on the next frame, when we get the player's previous position, we had stored it right when we left the previous frame's move function. Okay. So why do we have those two, previous and current distance? So all this is telling us, if the click location and where the player is such a small value, then there's no point moving anymore. It's going to be tough to have the player move on the exact pixels where you clicked. So this is kind of like our epsilon concept, where there's kind of a margin of error that you can allow. So for example, if current, we'll just use 1 for our margin of error, 1 pixel. We may have to fine tune this, but this is a good starting point. Or previous distance is less than, let's say 0, because it would be less than 1 because it was a previous location. Let's just try. These are values. We can fine tune them. They're just simply here to say we're very close to where that target position is, which is our button click or our touch. And if that's the case, let's just get out of this method and not move anymore. But also remember that is player moving concept. Set player moving is false, because he wouldn't be moving now, because he's basically at the target location, so he's no longer moving. You would have to click somewhere on the screen to make him move again. So set player moving, not get. So set him moving, and we return out. Brilliant. Okay. So now we want to make a copy of his current position. So we want to make a copy of this vec2, that 2-point vector. So let's go ahead and the reason why we're doing this is going to be his new position. We have to take the delta time, which is the elapsed amount in that second, and we want to use that speed we defined earlier today, which was 140 pixels, and then make him move, 140, but the fraction of 1/60th of a second. You'll see what I mean as soon as we start doing the code. So we're going to create a copy of his current position, because we want to use that as our starting point. And we're just going to add a little bit on his X and a little bit on his Y in the correct, and let me do this. We'll talk about what's going on. Player position. Cool. So we got a copy. Now, okay, so now let's set the new position. Set the new position based on the elapsed time, which is our delta t, for this frame. Okay. As well, we must take into account the angle at which the player needs to move. So not only are we making him move a little bit on the X and a little bit on the Y, but we have to know, are we adding a bit to the X or removing a bit to the X, right? So let's just let's assume this. Let's assume this. So I'm going to do a little drawing here. Let's assume this is kind of our game screen. And our player is right here. But I clicked down here where the C is. So now we know we got to move him just a fraction towards the click based on the amount of time that's elapsed. Like he wouldn't just instantly move there because it's one frame. I mean, that would be like 1/60th of a second. He's going to move a slight amount towards that direction because it's going to take him, he moves at 140 pixels a second, we defined. So let's say this is 200 pixels away. It's going to take him, you know, over a second to get there. So it's going to take probably, you know, maybe 80, 90 frames for him to reach there. So each frame, he's going to move just a minute amount towards the click. Now we have to take into account the angle though, for which that X and Y has to fluctuate. So it would actually be the X position on the player's position would slowly get smaller, not larger, because his X would be, let's say 10 and his X would be 100. So we have to get from 100 to 10 slowly. So we're going to slowly remove from the X to get to the C. But then we also have to know we're also slowly going down in Y because his Y, you know, starts at 0 here and goes up as we go up. His Y would also slowly decrease. If the click was over here, then the X would get smaller and the Y would get larger for the player to move. And then in this quadrant 2 on a Cartesian coordinate, it would be X and Y would be growing slowly. And then finally on quadrant 4, the X would be growing, but the Y would be shrinking. Okay. So we need not only the delta time to see how far we're going to move, but we need that angle, right? We need that angle we defined in that process event method earlier. Okay, so now how do we do that? Well, again, we got to play with a bit of trig, okay? We've got to use his target angle and apply cosine to the X and apply sine, the sine function, to the Y. It's really quite simple. So you'll see. So new position. And new position is a copy of his current player position. So this does hold the true X and Y of where the player currently is. So what we're doing is, I could use the compound operator plus equals, but we'll break it out because there's a bit going on in this statement. Position. And we'll work with X. So obviously we're setting the X to be its current X plus, let's move on a new line, plus the small fraction of time multiplied by the player speed. Remember, we defined get player speed as 140. So player speed should be 140. And we need to multiply now. So this kind of gives us how far he's moving, but we also need to know in what direction is he moving. So we just simply multiply in our cosine function against our angle. So we get that angle we defined earlier using our arctangent function. And that's in radians. So remember our radians. So let's go back to, it's a little harder to, I used to have one of those Whatcom tablets where you could draw, and I sold it on Kijiji. I wish I didn't, because I could plug that bad boy in. And since, you know, my computer doesn't have a touch screen, it would work as my drawing tool. I could just open up like Paint, MS Paint, and kind of draw what I mean. Oh well, bear with me. So a typical circle, you've got 0 at the top. That's 0 or 360 degrees. We'll work with degrees. I'll move that over a bit. And then we've got 270 degrees and I'm trying to draw out a circle, 90 degrees. And then remember the bottom of the circle's 180. So if we use radians, this becomes 6.28. This becomes, or really, I will say 2 pi. Forget the 0. Let's get rid of that. This is pi. This is 1.5 pi. And this is 0.5 of pi. So if our arctan function stored, let's say 1.552, if our target angle was 1.552, well, that's half pi, because pi is 3.14. So the target angle is saying we're moving directly to the right. Okay? If our arctan function, if our core get target angle returned back a float that was 3.14, then we know we're pi and we're moving directly south or straight down. Okay? So anyway, that's what this is, the radians. This will simply convert on that cosine function. You remember the sine and cosine were kind of exact opposites, but they were oscillating. They would move up and down, and they never reached higher than 1 or 0. You know what I'm saying? So they kind of always oscillated between 1 and 0. Well, let's go ahead and let's look at sine, cosine. And let's look at an image. This one looks like it might do the trick. So our sine function is the dotted or dashed line, and our cosine function is the solid line. So let's say we passed in pi to cosine. Well, pi is due south, right? We talked about that earlier. Pi is going in radians due south. So if we pass in pi into our cosine function, we're saying it's going to return back -1. So let's go back to our code. Cosine, if we were clicking due south, we're going pi radians in target angle. So this was 3.14. This guy would return back -1. So we know our x position is going to be going full bore at a factor of -1. You know what I'm saying? Because we know we're going due south, so x is going down at a negative rate, full bore. So if delta time, let's say, was 0.01 times player speed 140, so we get 1.4. Is that right, or is it 14? 0.01, 1.4. So he's going at the speed of 1.4 pixels in this frame, let's say. And because we're going due south, it's going at a -1 factor, which means multiply 1.4 by -1 gives us x now is going to be reduced by -1.4 pixels. So we're going south, full bore. Let's say he was going not quite south, but more kind of south westerly. Let's say just slightly off south, but more kind of with a few steps to the side, the west side. So now let's go back to our sine cosine part. Our cosine would now be closer to, it would be offset a little bit to the left of where my pointer is. And it would be not quite full on -1, but it would be higher than 0.5, -0.5. Let's say it's -0.8. So let's go back to that. Let's say our 1.4 multiplied by -0.8. Now we would be moving at a negative rate of x, but it would actually be not quite as fast because it's not full on south. It would be a little bit slower to go towards x because we're slightly offset. And then when we do the sine function to set our y, then the sine function is going to give us the y of a bit of movement towards the side, kind of give us our sideways shuffle a bit. So I don't know. I mean, hopefully that sort of makes sense. The important thing to note is, you know, when to use sine, when to use cosine. And basically in two-dimensional physics, you use arctangent between the delta of a y and an x to get you the radians of his direction he's moving in. So that's the first thing you need to know. Then the second thing you need to know is when you're moving him into that direction, you use the cosine for your x and you use the sine for your y, and you just multiply it by his speed, the small fraction of time that occurred in a second, and whatever the trig function returns. So anyway, if it doesn't sink in, that's okay. I mean, it's repetition, and maybe some of you haven't taken your trig yet. Maybe some of you have, like me, and you just hated it until you actually were forced to do it, right? So, and if you're like me and, you know, you hated it, that's fair enough. Some people, math just doesn't stick when you're young, right? Like, it takes time. All right. Get target angle. Cool. So exact same dealio for the y, except we're using the sine function. So cool. So now we've got his new position with his x and y defined based on that elapsed time. So let's actually set the player's new position. So let's go player, set, position, new position. And actually, it's not player position, which would be the previous position. It will be new position. And that will be used. That will be used in the next frame to check to see if we got a crazy jump going on. I think that's where we kind of used it up here. Okay, so we've got our new position, and that's kind of it. Let's actually just run this. Let's get rid of this stuff. Okay, let's see how we're doing. Cool. So I clicked, and he's going to where I'm clicking. We've got a bit of a problem though. You'll see I'm clicking, like let's say I click here, and he only comes down to touch on his 0, 0 position where I clicked. I actually want him to move right, like the actual middle of our player. I want to be right on where the click is. So we need to fix something. Cocos2d-x by default sets the anchor point, what's called an anchor point of a sprite, to the very bottom left-hand position. But in our case, we actually want the anchor point, or where his true center is, to be right in the middle. So we need to set his anchor point to 0.5. And we can do that. Where can we do that? We can do it when we initialize him. We can do it in there, but I prefer to do it on game layer in the init method. If we go to the init method of game layer, I think so. That's where we put him. Perfect. So right in this block of code, we created our player. We set his position to be the middle of the screen. This is at the start of our game, obviously. And we added him as a child to the layer, to the game layer. And then that just gets rendered by Cocos. That's fine. But before we add him, we should also set his anchor point to right in the middle. And that'll fix that problem. So let's go ahead and set anchor point. And it takes 2 floats, or I guess a vector 2, that's fine. Let's go vec2. And we want to define 2 floats. And one would be the top right-hand corner. Like 1, 1 would be in the far top right-hand corner. By default, it's 0, 0, which is the bottom left-hand corner. We want to be right in the middle. So 0.5 F for float and 0.5 F for float. So his X and Y are right in the middle before we add him. So now if we run the game, now if I click, he goes right to the middle. Oh, we've got some of our target fine-tuning to do, but for the most part, he is moving. So that's brilliant. So now what do we need to do? We got to add some bad guys, and that shouldn't be too difficult. I'll just basically make bad guys just as if they were sort of a player. They animate too. They just look a little different. And then we can add some logic in their update method to make them home in on the player and attack him if their colors are different. So we'll do that next. Unfortunately though, guys, I'm going to bail out and come back later on today to do that. I got some important calls to return here, I guess. So come join me later and we'll add the bad guy and do some interaction with him. So make sure you follow. Thanks, guys. See you in a bit.